Now that we've got the peeps, let's pick up the beat. Here we go. So you were asked to try to look at teams A, B, and C and make a prediction as to which one you think would win the marshmallow contest. And you guys have also created some launchers, so now let's take a look at some data that's been collected. So Team A used their catapult and hurled a marshmallow down the commons, and Mr. Walgate used a motion detector to collect the data while the marshmallow was in the air. He came up with this table shown. So our first task is to determine an equation that describes the path of the marshmallow, and then we need to talk about how we found that equation. Well, folks, there's a couple of different ways when we're given the data in a table that we can find the regression. Similar to how we found a linear regression, we can find a quadratic regression and get that line of best fit by using both Desmos or our graphing calculator. Let's take a look at how to do it by Desmos first. Okay, let's head into Desmos. And in Desmos, we're going to go ahead and make up a table. So we'll hit the plus sign. We're going to put in our values of our ordered pairs. So we have 719, 1290, 14101, 1990, 2155, 24, 0. Now that we have our data, we're going to run a linear regression by putting in the equation. So y, we're going to give it a sub 1, approximately, ax, and then again sub 1, squared, plus bx, sub 1, plus c. And then that gives us our regression. So we go ahead and shrink in our graph. And take a look at what that looks like. Okay, so using our A, B, and C values, we can now write our A value is approximately negative 1 3/10. The B value is 39 6400ths approximately, and our C value is negative 195 700ths. Okay, so folks, there's our equation from the linear regression using Desmos. Now, for those of you who have your graphing calculators, okay, we can also use those. You can see there's a couple cheat sheets there, which we have also posted to Google Classroom. And if you don't have a graphing calculator, there is an app that we can utilize, and let's take a look at how we do that. Another way for us to find a linear regression is using our graphing calculators. And if you don't have one of those, you can get the app that's called Graph, Grafn, Calc 83. It should be in self-service, and if you notice, it's located right next to my self-service app. When I open it up, it's going to look just like a graphing calculator, and we're going to find our quadratic regression, very similar to how we find a linear regression. First thing we're going to do is we're going to click on Stat, and we need to edit our list. So then I'm going to go to Edit, go down my list 1, and we're going to put in our x values. So 7, 12, 14, 19, 21, 24. List 2 will be our y values, so 19, 90, 101, 90, 55, and 0. Now that those are in, we need to run our regression, which means we're going to need to calculate that. So now I'm going to go back to Stat. I'm going to go to Calculate, and we need to find where it says Quadratic Regression. So on mine, it's located as number 6, so I'm going to hit Quadratic Regression. And I do have to designate on this what it is that we're working with. So my list 1, so I'm going to hit second in list. It's my list 1 is my x values, common. I'm going to hit second list. List 2 is my y values. And your guys is on your graphing calculators. That's probably already set up for you. So then you would just hit enter. And you can see that then gives us our A, B, and C values in order to write our quadratic equation. And that's how we find it on a graphing calculator. Okay, so now we've got our equation. So one more time, we've got y equals -1 and 31/100 x squared plus 39 and 64/100 x minus 195 and 7/100. So now let's take a look at questions B, C. So our next one is to graph the path of the marshmallow. So if we take our data and simply plot our ordered pairs, okay, we can construct that graph. But two key things that we're going to need to answer is, what is the maximum height of that? And how far was it actually hurled? So let's look at those two questions. Let's start with maximum height. If we're looking for the maximum height, we're looking for the vertex. So we can graph it by using our ordered pairs. So we have 7, 19, 12, 90, 14, 101, 19, 90, 21, 55, and 24, 0. So the path of the marshmallow is going to take this on approximately. So yes, we can find the vertex, hopefully just by looking at our graph. But if we want to be as precise as possible, let's remember how to use that equation to find the vertex. So our first step is to find that axis of symmetry, which is our opposite of b divided by 2a. So if we recall our equation, we have y equals -1 and 31/100 x squared plus 35 and 60, oh, excuse me, that's wrong. Let me backtrack there. Our b value is 39 and 64/100 x, and then our c value is 195 and 7/100. So if we take our opposite of b, 39 and 64/100 divided by 2 times our a. Okay, go ahead and take a minute on your calculators and let's get our answer to the nearest hundredth. And we should get 15 and 11/100. So that is our x value of the vertex. So as we take a look here, we get 15 and 11/100, comma. Now we plug that back in and let's find the actual height. So if we plug that in for our x, we have -1 and 31/100 x squared. But instead of the x squared, we're going to now go ahead and plug in our value for x, which is 15 and 11/100 squared plus 39 and 64/100, I'm going to run out of room, times our 15 and 11/100 minus 195 and 7/100. Let's go ahead and calculate that to the nearest hundredth. And when we do that, we're going to get approximately 104 and 197 thousandths. So we're going to go ahead and round that to approximately 104 and 2/10. So our vertex then would be located at 15 and 11/100 and 104 and 2/10. So folks, when it asks what's the maximum height that it reached, the maximum height is the y value of our vertex. So the maximum height is 104 and 2/10 feet. Right, now let's look at how far it has been hurled. So when we're looking at how far it's been hurled, that's the distance that it's traveled from here to here. So that's the same as finding our zeros of the function. And remember, our zeros can be roots, they can be solutions, they can be x-intercepts, they follow lots of different names. So in order to find those, when we have our equation, y equals -1 and 31/100 x squared plus 39 and 64/100 x minus 195 and 7/100. Okay, looking at that, it's not one that I think I want to factor or complete the square, and it does have a b value. So I would say that we go ahead and we use our quadratic formula. So let's use that opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And let's solve for our two zeros to find out how far it's actually been hurled. So if we take a look at our first zero, we have the opposite of, let's go ahead and plug in the b value. So the opposite of 39 and 64/100. And let's go with plus first, the square root of 39 and 64/100 squared minus 4 times our a value, which is -1 and 31/100, times our c value, -195 and 7/100. And then we're going to take all of that and divide it by 2 times our a value, which is -1 and 31/100. So that'll give us our first x value. Then we're going to follow the same thing with our second x value. The only thing that we will change is we're going to then make it a subtraction. So we have the opposite again of b. This time it'll be minus the square root of b squared minus 4 times a times c, all divided by 2a. Pardon me, hit that wrong button. Okay, let's take a minute. Let's go ahead and put those into our calculators, and let's find both of those x values. So now as we solve for those, we find out that we get approximately 6 and 1/10 and 24. So if we want to know how far it's been hurled, we need to look at the difference between those two values to see how far it has actually been gone between the two zeros. So 24 minus our 6 and 1/10. So it has been hurled approximately 17 and 9/10 feet. So we now have our data for part A. All right, now you're on to B and C.